Hey there, guys. We're getting ready to do finding rates of change and slope, and this is probably something you're pretty familiar with from your previous math classes. So our objective for the day is that you will be able to find the rates of change from tables and from data, and then you can also do it visually and algebraically. So let's start with the slope. The slope is the steepness of a line. And again, if you ever need to pause the video to copy this down, go ahead and do that. But it's the steepness of the line. And m is the variable that's used for slope, or the representation for slope. And slope is generally referred to as rise over run. You've probably heard that before. In your science classes, sometimes you use delta y over delta x. That just means the change. So that's the symbol that they use, or we can simply say it's y2 minus y1 over x2 minus x1. So that's what we've got going on here. And so this rate of change, it compares two different quantities, and the rate of change is equal to the change in your y values over the change in your x values. So that's pretty much what slope is, and you probably had much of that before. So when you generally read a graph, you want to determine if a line has positive, negative, no slope, or zero slope. Well, as it says here, you're going to read it like you read a book from left to right, and that's really important. So if I look at this graph number 1, I'm going to start over here on the blue graph, on the blue line, and I'm going to jump on there. And look, if I go to the right, it's going up. So this slope is positive. On graph number 2, I have to start on the left-hand side. So I have to start over here. So I'm going to start on the blue line here. But this time I'm going down. So that's a negative slope. Now on this one, if I start here and go across, there is no slope. So the slope is 0. Or you can say m equals 0. And this line, it goes straight up and down. So this has no slope, or the slope is undefined. That's what we call it. It's undefined. All right, so now we're moving on to finding the slope of each line given the graph. And again, you've probably been doing this for years. So remember, we want the rise over run. So I see my 2 points here, and I'm going to label them for us real quick. So here's point 1 and here's point 2. Now remember from the previous slide, it says we have to read our graphs from left to right. So if I look at my 2 points, this point here is more on the left than the 2 is. So I'm going to start here and go up. So I know I'm going to have a positive number. Okay, so now to find the rise, I have to decide how high do I go to get to point 2. So this is where you made those little triangles when you were younger. So my orange line is the rise, so it's 1, 2, 3, 4. And my turquoise line is the run, it's 1, 2, 3, 4. So my slope is my rise number, which is my orange one, over my run number, and that reduces to 1. So the slope of that line is 1. All right, moving on to the next picture. It's going up and down, and if you recall from the 2 slides ago, we said whenever it's doing that, the slope is undefined. Whenever this is the case, you're going to get an equation that says x equals something. 1, 2, 3. So this is x equals -3 because every ordered pair or point that's on this line has an x value of -3. It's going to be -3 something, -3 something, -3 something. All right, moving on to number 3, I'm finding the slope. Well, I know it's going to be a negative number, don't I? Because if I go back and think about that slide that we had earlier, if I start on the left-hand side and go to the right, I'm going down. So check this out. This is where the negative number comes from. So my rise is going to, I have to start at point number 1 and get to point number 2 as I go from left to right. So my rise is up or down, but this time I got to go down. So I'm going to go all the way down here, and then I got to go over all the way there. So my rise, since I'm going down, it's a negative number. 1, 2, 3, 4, 5, 6, 7. So it's -7. My run is 1, 2, 3, 4, 5, 6, 7, 8. So my slope is negative 7/8. All right, so this is a line, number 4, that is horizontal. So a horizontal line has a slope of 0. It's also going to have the equation y equals 1, 2, 3, 3, because every single point here is something comma 3, something comma 3, something comma 3. So all of my y's are 3. So that's the equation of that line. All right, we've come to checkpoint 1. So go ahead and find the slope of this line, and we will talk about it in class. Right now, you should already know if the slope is positive or negative, and then you're going to think about your little triangle and give me the slope. So go ahead and pause the video and do that, checkpoint 1. Now, if we think back to what we talked about earlier, we have an equation for slope. So make sure you write this down. M equals y2 minus y1 over x2 minus x1. That's the slope. Now, it doesn't matter which one of your points you use as the 1 or the 2, but I always just say, well, this is the first point, so it's x1, y1. That's what those y's mean. It's just the first one. And the second guy here, he's the second point, so this is x2, y2. Okay, does that make sense? So this 3 right here is my x1, the 5 is my y1, because it's the first ordered pair. And my 2 is my x2, and my 8 is my y2, because that's a second ordered pair. Okay? So to find my slope, I just use this formula. So that's how I set it up. I need my y2. Well, here's y2 over here, so that's the 8. And then it says subtract the y1. Well, the y1 is right here, which is the 5. So I have 8 minus 5. Now on the bottom, I need x2. So I have my 2 minus my x1, which is my 3. Okay, so I end up with 8 minus 5, which is 3, over 2 minus 3, which is negative 1. So my slope is negative 3. So that's how you do that using your slope formula. All right, so here we go for example 2. Find the slope of a line that passes between each pair of points. So we know the formula for slope is y2 minus y1 over x2 minus x1. Now remember, it doesn't matter which ordered pair you assigned x1 and y1, but I just say since this is the first point, it's x1 comma y1, and this is the second one over here, so he's x2 y2. Okay, so I just kind of use that to keep myself straight. And so for my formula, I have to subtract. So I need y2. So y2 is 3 minus y1, which is negative 7. Now don't be confused that you already have the subtraction sign there. You still have to put a negative 7 behind it, because that's what y1 is. Now I move to x2. x2 is negative 5 minus x1 is negative 2. So now that I have this, I have to find my answer. So I change that to positive, and I get 10 over negative 3. So that's my final answer. Okay, moving on to the next one. Find the slope of the line that passes between each pair of points. So again, my formula for slope is y2 minus y1 over x2 minus x1. So if I want to find the slope, I know it's going to be have a subtraction problem on the numerator and the denominator. So this is my x1, y1, and this is my x2, y2. Okay? So I need y2. So I come over here and I grab the 6 minus y1, which is negative 1. Now I move to the denominator. x2 is 5 and x1 is also 5. Okay, so now I have 7 over 0. Well, we know we can't do that, so my slope is undefined. And what that means is if you look up here, the x values are both 5. So that means I have a line that looks like this. So this line is called x equals 5 because the slope is undefined. All right, moving on to number 4. Find the slope of the line that passes between each pair of points. Well, I have y2 minus y1 over x2 minus x1. Okay, so again, here's my x1 and my y1. Here's my x2 and my y2. So there's my two ordered pairs. So I set my equation up. So I need y2, which is 1, minus y1, which is also 1, over x2, which is 2, and x1, which is negative 2. Now wait a minute. I get 0 over 4. Well, 0 over 4 is 0, so my slope is 0. So one way you can always see if the slope is 0 is if you look at the y values are the same. So what this is going to look like is I'm going to have a graph, and the line is going to come through here at 1. So this is y equals 1. That means every y value on this line has a value of 1. All right, find the slope of each function given in a table. So when we're given a table, if a line has a slope of 2, it always has a slope of 2. If it has a slope of 1/2, it has a slope of 1/2 everywhere. So we have to check the slopes everywhere. So the way I do that is I look at the difference between the x values. So the difference here is 2, the difference here is 2, the difference here is 2, and the difference here is 2. So that's x minus x, x minus x. So when I do my y minus y, I have 2 minus negative 6. So I have 8. Here I have 10 minus 2, which is 8. Here I have 18 minus 10, which is 8. And here I have 26 minus 18, which is also 8. So my slope, I look at these fractions. So I have y over, change in y over change in x. Does that equal 8 over 2? Yes. Does that equal 8 over 2? Yes. Does that equal 8 over 2? Yes. So it says, is it linear? Yes, because lines have constant slope. That means the slope is the same between the pairs of values on the table. All right, I have the same type of question again. Find the slope of each function given its table, and then is it linear? Well, remember, I'm going to check to see if the change in y over the change in x, which is the slope, is consistent throughout my table. Last time I started with my second number of each pair. This time I'm going to start with the first number. So I'm going to start here. So I'm going to subtract them and see what the difference is. And in this case, I have negative 7 minus negative 4, so I get negative 3. Now I'm going to check this pair. So again, I'm going to start with the top value, negative 4 minus negative 1, which is negative 3. Now I'm going to start with a negative 1 minus 2, which is negative 3. And then finally I have 2 minus 5, which is negative 3. So my x values look good. Now for my y values, I have to do the same procedure, but remember you have to have the same relationship. So I have to start with my top y value as well. So I have 5 minus 4, which is 1. I have 4 minus 3, which is 1. I have 3 minus 2, which is 1. And I have 2 minus 1, which is 1. So it looks good so far. So really the slope is going to be my change in y, which is 1, over my change in x, so negative 1/3. So is it linear? Yes. And the reason is because it has a constant rate of change. Constant means it's the same. Alrighty, moving on to table 3. I want to see if my change in x's and my change in the y have the same relationship. So I'm just going to start. On the right. So in this case, I'm going to do 8 minus 12, which is 4. Negative 4. Then I'm going to do 12 minus 16, which is also negative 4. Okay, so far so good. Now I'm going to do 16 minus 20, which is also negative 4. Okay, and then 20 minus 24, which is negative 4. All right, so my x's look okay. but I have to check my y's. Because there's a constant rate of change of the x's, there has to be a constant rate of change of y's for it to be a line. So since I started with the 8 and did 8 minus 12, I have to start with the 7 and do 7 minus 5. So I have to do 7 minus 5, which is 2. Okay? So in this case, I have to do 5 minus 3, which is 2. Then I'm going to do 3 minus 0, which is 3. Then I do 0 minus negative 2, which is 2. Okay, I have a problem here. This 3 doesn't make the rate of change constant. Because my x values are all negative 4, I was expecting my y values to all be the same, and once the pattern of 2 started, that's what I believed it were to be. So this is not linear because there is not a constant rate of change. All right, here you are at checkpoint 2. I would like for you to write checkpoint 2 in your notebook and do this problem and determine whether or not the function represented in this table is linear, and we will talk about this in class. All right, example 4. Example 4 is asking you to find a value of r so that the line going through these 2 points has a slope of 1/2. Well, they're just wanting you to practice your algebra here because you know the formula for slope is y2 minus y1 over x2 minus x1. Normally, we're trying to find the m, but they've given us the slope, which is our m. So we're going to replace the m with a 1/2, and then I have y2 minus y1. Well, I'm just going to label these points real quick so I don't get confused. Here's my x1 and my y1, and my x2, which happens to be an r, and my y2. All right, so my y2 is 2, my y1 is 3. In the denominator, my x2 is r, and my y2 is 6. So big deal. Who cares if I have this r? I can do this because I know algebra. So I have 1/2 equals negative 1 over r minus 6. Well, would you look at that? We have a proportion, don't we? Don't we have a proportion? We have a proportion. So what we do is we have to cross multiply and divide. So I'm just going to recopy this. So when I cross multiply, I'm going to go this way. So 1 times r is r, minus 1 times 6 is 6, and that's equal to negative 2. So I add 6 to both sides, and I get r equals 4. So my solution is r equals 4. If I put a 4 in for x2 or r, then that line is going to have a slope of 1/2. All right, nice job. I'll see you in class.